Welcome back. Now, securitygroups.tf. We have spent this entire week talking about roads, route tables, whether a road exists between two neighborhoods at all. Security groups are something different. A security group does not decide whether a road exists. It decides who is allowed through the front door of a specific building once they have already arrived on the right street. Think of it like a bouncer standing at the entrance of one specific building, not the street, not the neighborhood, one building, one door. Even if the road exists, even if the route table allows the traffic to arrive, the bouncer still checks, are you actually allowed inside this building? One more important thing, security groups are stateful. If you let someone in the front door, you automatically let them back out. You do not need a separate rule for the return trip. The bouncer remembers who they just let in. That is different from a road existing. That is about who gets past the door. First security group, VPC Endpoints. Port 443, HTTPS only. Remember the interface endpoints we built last time, Kinesis, every other AWS service that is not S3 or DynamoDB. Those endpoints need a security group attached to them. This is that security group. CIDR blocks, all 6 VPC CIDRs listed. This bouncer allows traffic from every single neighborhood we have built: production, HR, finance, DevOps, staging, QA. Why all 6? Because every neighborhood needs to reach AWS services privately. The endpoint does not care which department you belong to. It only cares that you are HTTPS traffic coming from inside ABSA's own address space. This is the front door for talking to AWS services privately, open to the whole bank, closed to anyone outside it. Second security group, the ALB, 0.0.0.0/0. Anyone, anywhere on the internet. This is the only security group in our entire architecture that opens its door to the whole world. And that makes sense because this is the application load balancer, the actual front door of the bank, the thing Sipo's phone talks to when he opens the ABSA app. Port 443, HTTPS, encrypted. Port 80, HTTP. Why allow that at all? Only to immediately redirect it to HTTPS. Nobody's traffic stays unencrypted. Port 80 exists purely to catch anyone who typed the wrong address and push them to the secure version. This is a placeholder for week 4 when we build the actual application layer. But the front door needs to exist now, ready and waiting. Third security group, the application tier. Look closely. Security groups, not CIDR blocks. This is one of the most powerful ideas in AWS networking. Instead of saying, allow traffic from this specific IP address, we say, allow traffic from anything that belongs to the ALB security group. Think of it like a wristband at an event. The bouncer at this door does not check your street address. The bouncer checks, are you wearing the ALB wristband? If yes, you are in. It does not matter what your actual IP address is. Why does this matter so much? Because the ALB can scale. It can get new IP addresses tomorrow, new servers, new instances. If we had written a fixed IP address into this rule, it would break the moment the ALB changed. By referencing the security group itself, the rule keeps working automatically, forever, no matter how the ALB grows or shrinks. That is dynamic security, not based on addresses, based on identity. Fourth and final security group, the data tier. Port 5432, PostgreSQL. Port 6379, Redis. Port. Same wristband pattern, not the ALB's wristband this time, the application tier's wristband. Only traffic wearing the baseline app security group is allowed to reach the database, not the internet, not the ALB directly, only the application layer. Look at the chain we have just built. The internet reaches the ALB. The ALB's wristband reaches the app tier. The app tier's wristband reaches the data tier. 3 doors, 3 bouncers. Each one only trusts the wristband of the layer directly before it. The internet cannot skip straight to the database. There is no rule anywhere that allows that. The only path in is through every single door in order. One last detail. Look at the egress blocks. Egress, wide open, anywhere, any port. At first glance, that looks dangerous. Why would the data tier be allowed to send traffic anywhere on the internet? Read the description again. Controlled by root tables. Remember the data root table we built. No route to the internet gateway. No route to a net gateway. Not even one. It does not matter that the security group says egress is allowed. There is no road for that traffic to actually travel on. The bouncer says you can leave, but there is no door leading outside. This is layered defense. Two completely independent systems agreeing with each other. The root table decides if a road exists at all. The security group decides who is allowed through a specific door. A database in this architecture is protected by both at the same time, independently. If one layer ever has a mistake, the other layer is still standing. That is what real defense in depth looks like, not one wall, two.